Hello. This is Superworld Chorword. In this report, we will take a closer look at Nvidia's robotic engineering, namely the field of robotics. The key point is that amid increasingly fierce AI chip competition, Nvidia is positioning robotics as a new growth engine. Nvidia plans to launch a next-generation ultra-compact computer called Jetson Thor for humanoid robots in early 2025. This can be considered a crucial milestone in the field of robotics. In particular, Deepu Talla, Nvidia's vice president of robotics, stated that a ChatGPT moment coming soon in the realm of physical AI and robotics, implying that robots are nearing a critical point of acquiring human-like intelligence. In this slide, we discuss the competitive landscape Nvidia is facing. AMD, Amazon, AWS, Microsoft Azure, and Google GCP are all accelerating their own AI chip development to reduce dependence on Nvidia. Nevertheless, driven by the soaring demand for AI chips, Nvidia surpassed a market cap of $3 trillion, roughly 3,000 trillion won. This figure still demonstrates Nvidia's leading position in the market. Looking at slide 4, you'll see that the robotics business still accounts for a small portion of Nvidia's total revenue. Of the $35 billion, about 46 trillion won in revenue for Q3 2023, 88% comes from data centers, the AI GPU segment. This also indicates that robotics is still in its early market phase. Slide 5 introduces Figure AI's a major investment case. It's a company in which Nvidia, along with Microsoft and OpenAI, invested in February 2023 with a valuation of a staggering $2.6 billion, roughly 3.5 trillion won. Because it is a humanoid robot startup, it signals advancements in the robotics field. Through collaboration or investment with such startups, Nvidia is expanding the robot ecosystem. Moving on to slide 6. The first technical breakthrough is generative AI models. When AI capable understanding human language and supporting complex problem solving is integrated into robots, can expect a significant boost in user-friendliness and accuracy. This literally suggests that a ChatGPT moments could also arrive in the field of robotics. In the past, you had to program commands, but in the future robots will learn data on their own and make decisions according to the situation. Slide 7 introduces the second technical breakthrough, simulation learning. Robots are trained in a virtual environment, and those results are then applied to the real environment. This is called the sim-to-real gap. With Nvidia's Omniverse platform, high-quality 3D simulations have become possible, significantly reducing the costs and time of robot testing and development. This is a critical factor in enhancing efficiency across the robotics ecosystem. Slide 8 shows how Nvidia Robotics has evolved. Since Deepu Talla joined in 2013, working on Tegra chips for smartphones, and after creating the Jetson Robotics module in 2014, the accumulated technical expertise has been vital to its progress. They provide a comprehensive robotics solution by offering everything from AI model training, software, and the Omniverse simulation platform to hardware chips for robots. Finally, let's draw some conclusions from slides 9 and 10. The AI chip market will grow increasingly competitive, but Nvidia has broad opportunities in robotics. In particular, Jetson Thor's, slated for release in 2025, is expected to serve as the brain for humanoid robots and drive full-fledged market expansion. Crucially, the combination of generative AI and simulation technology will accelerate the kind of innovation in the robotics field that we might call a ChatGPT moment. Although Nvidia's investment in robotics is still relatively small, It is expected to become a highly important growth axis in the long run.